Understanding the Modbus RTU frame structure is crucial for seamless communication in industrial automation. Imagine the frame as a meticulously designed package, where each component plays a vital role. The frame starts with an address field, which identifies the slave device. Following this, the function code dictates the action to be performed, such as reading or writing data. Next, the data field contains the actual information being transferred. Finally, the frame concludes with a cyclic redundancy check, CRC, for error detection. Mastering the structure ensures reliable and efficient data exchange. And here's why that matters: a well-constructed frame minimizes error. Now, let's dive into the underlying theory of Modbus RTU frames. Imagine a Modbus RTU frame as a meticulously crafted message, designed to travel efficiently across serial lines. Each frame is composed of several critical components: the slave address, function code, data, and error checking field. The slave address identifies the specific device you're communicating with. The function code tells the device what action to perform, whether it's reading or writing data. The data field contains the actual information being transferred, and the error checking field ensures the integrity of the data. Understanding these components is crucial because they form the backbone of every Modbus RTU communication. This is why mastering them will give you unparalleled control over your serial communications. And here's why that matters: when you grasp the theory behind Modbus RTU frames, you're not just learning to communicate, you're learning to command and control with precision. Now, let's delve into the initial configuration of Modbus RTU frames. The first parameter you need to set is the slave address. This is a unique identifier for each device on the network. Typically, it ranges from 1 to 247. Next, configure the function code, which dictates the type of operation to be performed. For reading data, use function code 3, and for writing, use function code 6. Remember, the data length parameter is crucial. It specifies the number of registers to be read or written. For instance, if you're reading 10 registers, set this value to 10. And here's why that matters: incorrect configuration can lead to communication errors or even device malfunction. So, now, let's delve into the execution logic of Modbus RTU frames. Imagine each frame as a meticulously crafted message, designed to travel across the serial line with precision. The master device initiates communication by sending a request frame. This frame includes the slave address, function code, and specific data fields. Upon receiving the request, the slave device processes the command. It's crucial to understand that the slave device must respond within a predefined timeout period, typically 1 to 2 seconds. If the master doesn't receive a response within this window, it will retry the request. The response frame from the slave mirrors the structure of the request but contains the requested data or status information. Remember, error handling is vital here. If an error occurs, the slave will send an exception response, indicating the nature of the error. This ensures that the master can take appropriate action, whether it's retrying the command or logging the error for further analysis. Optimizing Modbus RTU frames is crucial for efficient communication. Start by minimizing the frame length. Reduce the number of registers you read or write in a single transaction. This decreases the time each frame spends on the bus. Next, adjust the baud rate. Higher baud rates can increase throughput, but ensure your devices support it. For instance, setting the baud rate to 19,200 Oregon 38400 can significantly improve performance. Additionally, implement error checking efficiently. Use the CRC, cyclic redundancy check, method, which offers a good balance between error detection and frame size. Remember, each byte added for error checking reduces the payload capacity. Lastly, consider the inter-character timeout. Set it to the minimum value that still allows reliable communication. Now, let's dive into the common pitfalls you might encounter with Modbus RTU frames. One of the most frequent issues is incorrect baud rate settings. Ensure your baud rate is set to 9600, which is the standard for most Modbus RTU applications. Another common mistake is misaligned data bits. Always verify that your data bits are set to 8. Incorrect parity settings can also cause communication failures. Use even parity for most applications, but double-check the device specifications. Lastly, be mindful of the stop bits. Typically, one stop bit is used, but some devices require two. Addressing these settings will significantly reduce communication errors.